10 p.m. only on Science Channel.
Deconstructed. You keep yours. We'll break ours. The glucometer. A pocket-sized laboratory that determines the glucose level in blood. Vital information for diabetics. Glucose is a type of sugar. It's the body's main source of energy. Diabetics tend to have too much sugar in their blood. This condition must be monitored. Knowing their blood sugar level on demand allows diabetics to take action to control their condition. The glucometer makes this possible. How does something so small manage to do something so important? All these parts work together and use sugar to make electricity. But to do that, it needs some blood. Just a drop. That's where the lancing device that comes with the glucometer comes in handy. It can draw that small drop of blood neatly and quickly. The device consists of a spring and a retractable lancet, or blade. Once it's armed, the blade draws in and the spring compresses around the stem. Press that release button and the blade punctures the skin in a split second. Both the spring and the lancet then return to their original positions. It's the glucometer's job to analyze this tiny drop of blood. It all happens in the test strip, in a special chamber, the reaction chamber. The blood is drawn up the test strip into the reaction chamber. Then, the glucometer determines the amount of sugar that's in the blood sample. Only seconds later, that measure appears on the glucometer screen. Vital information available in a matter of seconds. Inside the glucometer, there's a battery, a printed circuit board, and a test strip dispenser. This dispenser is placed on a rotating disc. With a pull of the meter's handle, the disc rotates a notch. As the handle slides back into place, a metal triangle pierces a test strip envelope, pushing a strip from the cartridge. It's in this test strip that blood sugar is used to make electricity. That's what allows the glucometer to determine the level of sugar that's in the blood. Electricity is made up of particles even smaller than atoms, called electrons, that zoom along in a given direction. Sugar, like electricity, also has electrons. So sugar can be used to make electricity. The battery in the glucometer provides the electricity. It sends electrons traveling through the test strip's reaction chamber. As the electricity flows through the reaction chamber, the sugar electrons in the blood sample join the flow of electrons. More sugar, more current. It's the printed circuit board's job to analyze the current, so it can determine the amount of sugar in the blood sample. It's up to the special lab-generated proteins lodged in the test strip to rip out those sugar electrons. Over in the reaction chamber, sugar molecules in the blood fly around, bumping into the test strip's special proteins. The proteins grab the sugar molecules and destroy their shape. When that happens, the sugar molecules release electrons. That boosts current. And the printed circuit board registers the surge in current. That change, due to added sugar electrons, becomes the amount of sugar found in the blood, which the glucometer measures in thousands of moles per liter. What are moles? Simply put, they're the scientific unit of measure for molecules. A reading of 2.8 thousandths of a mole per liter of blood is too low. At 13.9, the level's too high. The glucometer is able to determine these sugar levels by using that sugar to make electricity. All that in a device that fits in the palm of your hand. The glucometer, one sweet piece of equipment. Next, on deconstructed, the humidifier. It uses sound literally to atomize water to create a cool, fine mist.